All right, let's jump right in. Picture a bustling Nigerian market. Sounds chaotic, right? Well, hidden inside a common packaging problem is a pretty cool mathematical secret. Today, we're going to unravel this mystery and see how a simple idea can bring perfect order to all that chaos.
So, this really brings us to the core question, doesn't it? How can a simple, maybe even basic, math concept solve a really tricky, real-world problem like this one? You'll see the answer is surprisingly powerful. And trust me, it's useful way beyond just the marketplace.
Okay, let's get into it. Our story starts with a woman named Auntie Taupe. She's at the famous Dugby Market, and she has a real puzzle on her hands. So here is her dilemma. She's got yams, and she's got dried fish, and she needs to pack them into these gift boxes for a customer. But, and this is a big but, there are rules. First, every single box has to be identical. Second, each box needs to have the largest possible number of items in it. And third, and this is absolutely crucial, there can be nothing left over, zero waste. So how in the world does she figure that out?
To solve this, we kind of need to become detectives, you and me. And our very first clue is a little concept called factors.
So what exactly is a factor? Well, it's just a whole number that divides another whole number perfectly with nothing left over, no remainder. You can think of them as a number's basic building blocks. And believe me, they are the absolute key to cracking Auntie Taupe's code. Okay, let's make this real with her 15 yams. She could pack them in a few different ways, right? She could do one big group of 15, or maybe 3 groups of 5, or even 5 groups of 3, or 15 tiny groups with just 1 yam each. The numbers 1, 3, 5, and 15, those are the only ways she can group them up perfectly. And those are the factors of 15. All right, so that takes care of the yams, but what about her 20 bags of dried fish? Remember, each gift box has to have both items, so that means we need to find the factors that the yams and the fish have in common. Okay, check this out. We've got our clues all laid out now. The factors for her 15 yams are on that top line, and the factors for the 20 bags of fish are right below. Now just look, which numbers show up on both lists? Yep, it's just 1 and 5. Those are our common factors. And just like that, we have everything we need to solve this whole mystery. The answer has a special name. It's called the highest common factor. The highest common factor, or HCF for short, is, well, it's exactly what it sounds like. It's the biggest or highest number from that list of common factors we just made. You can almost think of it as the highest chief that's going to step in and organize everything perfectly for Auntie Taupe. So let's go back to our list of common factors for the yams and the fish. It was a short list, right? Just the numbers 1 and 5. So the highest number on that list is, well, it's pretty obvious, isn't it? It's 5. And boom, that's the solution to her entire problem. The HCF is 5. This tells Auntie Taupe she can make exactly 5 identical gift boxes. So what goes in each one? Well, she takes her 15 yams, divides by 5. That's 3 yams per box. She takes her 20 bags of fish, divides by 5. That's 4 bags per box. And just like that, perfect, identical packages with absolutely nothing left over. Mystery solved. Okay, so listing out all the factors works great for smaller numbers like 15 and 20, but what if Auntie Taupe had a huge order, like 180 yams and 240 bags of fish? Phew, we'd be here all day listing factors. We need a faster way, a shortcut. Let's call it the prime factor fast track. Don't worry, it's actually a really simple 3-step process. Step 1, you break down each number into its prime factors. You know, those special numbers like 2, 3, 5, 7 that can only be divided by 1 in themselves. Step 2, you look at both breakdowns and circle the prime factors they have in common. And finally, step 3, you just multiply those shared prime factors together. That's it. That's your HCF. It's so much faster. Let's try it out with a quick example. Let's find the HCF of 12 and 18. First, we break down 12. That's 2 times 2 times 3. Got it? Then we break down 18. That's 2 times 3 times 3. Now, we just look at both lists. What do they have in common? Well, they both have 1, 2, and they both have 1, 3. So what do? We take those shared primes, the 2 and the 3, and we just multiply them together. 2 times 3 is, of course, 6, so the HCF of 12 and 18 is 6. See how fast that was? And the best part is, this powerful shortcut works every single time. I don't care how big the numbers get. Okay, so now that we've got this awesome skill, there's one more thing we need to talk about. It's really important not to get it confused with a similar sounding concept, the lowest common multiple, or LCM. Knowing the difference between them is totally key to making sure you're solving the right kind of problem.
It's actually pretty simple when you think about it. The HCF, the one we've been working with, is all about splitting things into the largest possible equal groups. You can think of it as dividing down. The LCM, on the other hand, is about figuring out when two things that repeat are going to happen at the same time again. That's about meeting up. So a simple way to remember it: HCF is for grouping things, and LCM is for timing events.
And that pretty much brings us to the end. We started in a busy market in Ibadan, and we ended up with this really powerful mathematical tool. It kind of makes you wonder, doesn't it? What puzzles in your own life? Maybe something like organizing party favors or planning a project or even tiling a floor. What problems could you solve just by finding that highest chief, the highest common factor?